What's up, Arc Junkies? Welcome to episode number 243. While I was out at the Welding Summit, I met some really cool people. One of them happened to be a young welding engineer. And now I know you're thinking, welders and engineers, they don't typically get along. But Paisley Natalia isn't your typical welding engineer. She likes to get in the shop and work side by side with the welders that are making the repairs. She doesn't try to do her job from behind the desk. She goes right out to where the work is and solves the problems and gets a better understanding of how and why things work to solve in-service issues. We'll get right into her story right after a quick word from the supporters of the show. Today's episode of the Arc Junkies podcast is brought to you by Rockmount Research and Alloys. They make the rods and wires you need for the most difficult repairs in the most undesirable conditions. These are the conditions maintenance welders have to deal with on a daily basis. The equipment is typically covered in mud, dirt, paint, oils, and all kinds of other crap that makes standard electrodes ineffective to make a lasting repair. Rockmount rods are different. They excel in this type of area. At first, I thought Rockmount rods were just snake oil until I tried them for myself. I painted up some plates, covered them with sand and cutting fluid, and welded right over the top of them with no porosity, no undercut, no cold lap, and achieved great penetration at lower amps than the equivalent diameter of a 6010 or a 7018. Rockmount rods are legit, and they boast a higher percentage of elongation and higher tensile strength than rods and wires meant for initial fabrication. Rockmount makes rods and wires for every situation, whether it's cast, low alloy, stainless, dissimilar alloys, and more. Check out their full line of products at rockmountwelding.com. And while you're there, take a look at their abrasives, blades, bits, and welding chemicals, and save 10% off your purchase when you use Arc Junkies 10 in the discount box at checkout. Get the job done right the first time, every time with Rockmount. We're also brought to you by Outlaw Leather, makers of the finest custom handmade leather goods in the welding industry. With Outlaw, your imagination is your only limitation. They can put just about anything on a custom-made welding hood, whether it's your favorite sports team, branch of military service, your company logo, or your school logo if you're a welding program. If you can dream it, Outlaw Leather can put it on a hood. I've seen them come up with some crazy pieces based off someone's vision on a napkin. These guys are seriously talented, but it doesn't stop there. Outlaw Leather goods are handmade in the USA at their facility in Pasadena, Texas, from the highest quality of leather available to build you a product that's gonna last. Check them out online at outlawleather.com, where you can tour their full line of custom leather goods, as well as their other tools and accessories they have in stock to keep you up and going, like layout tools, grinding wheels, gloves, PPE, and much more. And if you buy any of their in-stock leather goods, you can use Arc Junkies in the discount box at checkout and save 15%. That's outlawleather.com. We're also brought to you by Levrack, the ultimate storage solution for your home shop or business. Levrack makes storage, saving space, and organizing super easy and convenient. The Levrack system is built super solid right here in the USA and can hold over 3 tons of capacity. Levrack combines the best elements of industrial pallet racking and mobile aisle shelving. Their patent-pending suspended high-density shelving system maximizes your current storage capacity and provides a clean, organized, and efficient alternative to ordinary static shelving. That's what I love about this product. The mobile aisle storage system allows me to store my items vertically in a convenient shelving system, saving me precious floor space. The Levrack system is designed to fit your needs. With multiple sizes, workstation add-ons, accessories, and racking options means your Levrack system fits your space and workflow. You can get a turnkey system or customize a system that fits your exact needs. Check them out at levrack.com today and find the storage solution you've been looking for. All right, you know what time it is. Fire up your machine, drop your hood, and turn me up 5.
You're listening to the Arc Junkies podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
So Paisley, what brought you down here to the Welding Summit?
Came down to come shake hands, kiss babies, meet a lot of people that I've been interacting with over the past year, 2 years, virtually. Network, come out and see a lot of the awesome presentations and all that. So, yeah.
Okay. So you're based out of Canada.
Yeah,
and
that's
you came all the way down here. Like, you guys have your own welding gear up there. So what was it that, about AWS that kind of brought you down to the U.S. And cross the border and learn something about, the way we do things down here?
Yeah, well, first of all, I love America. You got Chick-fil-A, you got cowboy boots, which I've got a new pair on right now, right? So we do have a CWB up there. It's not as large as the AWS or whatnot. I find the AWS has a lot more interactions. There's a lot of stuff more going on, more committee meetings, more this, right? There's some really good information and people out there, so that's why I came down.
So it's a little bit more active than what CWB is in your area?
Yeah, in my area anyways. Right?
Okay.
Yeah.
And then, so tell me about your background, because I found it pretty fascinating. You're a welding engineer that actually welds, because most of the time you run across welding engineers. I talked a little bit about this with Scott earlier this week, that a lot of welding engineers, they don't weld. And I think that's a big thing. Like, if you're going to get into welding engineering, you should at least, strike a couple arcs, drop the hood, understand how to read a puddle, what all is going into this process before you start writing procedures and all that. Totally.
Yeah, no, exactly. Yeah, no, I feel it's one of the most important things, and probably that sets me aside amongst a lot of the welding engineers, is that, I have no problem getting my hands get dirty, being out in my coveralls, up and down, all this, right? You just kind of get back there. It's fantastic.
So did you start off welding first, or did you start off welding engineering?
No, so crazy story. I actually started in automotive engineering.
Okay.
Right. Found my way over to the Canadian oil sands up in Fort McMurray, Alberta, if you're familiar with that. And then from there, funny story, I started dating a Boilermaker, right? I know, sorry for that. But, he got me into welding, and I was like, man, this is freaking cool shit, man. Like, you can do so much, so much. So, I started out welding on. Sorry, I'm a little nervous.
Don't be nervous.
I've never done a podcast before. Started welding on pancakes and all that, and then just like blind flanges, and then got into some gouging as well, and then start putting stuff together and overlays and all that, and then start doing procedures, when you walk into the shop and the guys are like, oh, here comes the welding engineer, oh, this, that. And you're like, hey, pass me a hood. Like, I want to see what's going on. Let's talk about this. What's going on, guys? Yeah.
So what type of welding were you actually doing? So were you welding while you were obtaining your engineering degree as well?
No, so this is all after I got my engineering degree.
Okay.
But I started on stick welding. I've done some TIG, MIG, some flux core as well, right? A little shaky on the flux core, I'm not going to lie, but.
I love flux core. Well, self-shielded and gas shielded. I think they're both highly underrated.
Yeah.
I love running both of those processes.
Yeah, it's tricky. Like, my biggest thing was, especially on the MIG, and I was doing some STT and whatnot. Man, she goes fast. Like, you can lay a lot of metal down. It is crazy. I was like, oh my gosh, my wire's going everywhere. It's nuts, right? Getting big old grapes underneath. Mm-hmm. But, yeah.
So now what do you do for, a full-time gig? Like, you're a welding engineer for, what type of industry?
Yeah, so I'm predominantly in the oil and gas, right? I now work internationally. Surprisingly, I actually do a lot and most of my work in the States, although I'm based in Canada. I do repairs, turnarounds, trainings, all that. So anything from you walk in and people are like, what is a WPS, to very, very complicated in-service age repairs that are like, hey, this plant went down very unexpectedly. We need to get this bad boy up and running. So how are we going to get it, fixed up and all that?
Yeah. Yeah, because we were talking, I think it was Tuesday night, you and Scott and I were kind of hanging out and shooting the breeze, and you guys were talking about some really cool stuff as far as repairs, because petrochemical, that's an area I'm not too familiar with. It's something I'm wanting to get more into. I kind of want to expand my horizons a little bit. But, what are some of the common repairs that you guys are doing, and what are some of the things that has to go into that?
Yeah, so common repairs. My favorite are the stainless repairs and all that, especially things that have been aged in service. You get into these metallurgical phases after a specific amount of time and at temperatures or whatnot. So, and they can be very challenging to weld on. They just crack and brittle like a motherfucker, to put it frank, right? So it's like, how are we gonna be able to do this when you put a bead down and she just keeps cracking? Like, let's figure that out. Reformers, so steam methane reformers, one of my favorite pieces of equipment. I freaking love them. Those outlet manifolds with some very sophisticated and sexy metallurgies. Same thing, they get pretty aged and cooked up and very challenging to repair.
So now when you have these aged pieces of material, when you go back in to make a material, or when you go back in to make a repair, you're obviously putting in new material. So how do you artificially age, so that once you put brand new material to old material, I mean, you got to kind of match it up, the metallurgy as close as possible to prevent cracking. How do you do that? Is that just done by different heat treating?
Yeah, so there's a kind of different approaches you can do. My favorite thing, and most people aren't too keen on this, is solution annealing, which is exactly like you said, heat treatment, where you take an old material, and sometimes it's not even welding an old to new, sometimes it's just repairing an old, or you get the new to old or whatnot. So you'll go through and you do these heat treatments when you bring the temperature up so he's cherry freaking red, right? And then you get them up, you hold them up there to a specific temperature in your soak time, and then you take all the heat off bat out of hell and cool them down, so you really lock in that metallurgical structure to ensure hey, we're going to be able to weld on this and bring it back into the phase as close as you possibly can anyways. It's never going to be 100% as new. And then it's much more easier to weld on. Right, you really restore those weldability properties versus something that's aged and cooked. Yeah,
and that's the cool thing about it is once you I do a lot of generic stuff like steel, stainless, aluminum, nothing too exaggerated. We have to do post weld heat treatment and all that stuff. But talk a little bit more about grain refinement. So when we heat up stainless, you get all these molecules moving around. How do you guys know? Once we get the specific grain structure that we're looking for, okay, that's when we're going to go ahead and put the post-weld heat treatment at a pause, and then we're going to go ahead and quench it.
Yeah, so it really depends on typical thing of a welding or metallurgical engineer. It depends, right? So every material is different. Every service is kind of different or what, depending on the thickness, the component, how was it made, etc. A lot of it, there's a lot of really good research out there that's already been done and is being done by manufacturers, by people like AWS, by people like MTI, which is the Material Technology Institute, etc., etc. So you go through, and depending on the size, the metallurgy, there's a lot of the known temperatures, and you put it up. The biggest thing is getting the right heat treatment companies out there and getting all your thermocouples, making sure that you're actually at your temperatures for the entire component or whatnot. And then, you'll go from there. You sit down, you're like, okay, have we got to this temperature? This is the known temperature range, and it's always a range. It's never 1,000 Fahrenheit or whatever. Only, there's 1,000 to, 1,500 or whatever the range is, right? And then you hold it there in your soak band to make sure you've got all the heat into the component to ensure that, like you said, that refinement or the grain structure is changing off of there to get back to that as new condition, as close as you can anyways. And then, you take your pads off and either you quench it or slow cool depending on the metallurgy. But,
Now, how critical is that, the accuracy of the thermocouples and, what you're using to make sure it's at that temp for that specific time? I mean, you guys have a tolerance to be we could be, 200-300 degrees plus or minus and still be within that range? Or is it a little bit more tighter tolerance to say, hey, if we get out of this, 20-30 degrees, that could be the difference between, another repair or, it actually going into service?
Totally. So it really, again, depends.
Depends on the type of material.
Yeah, there's so many things. And I know people get frustrated with welding and metallurgical engineers because they ask questions it depends. But some metallurgies, you have a very tight-knit range, right? Upwards of 50 degrees Fahrenheit or so, and some you can have 100 plus around there. And again, it comes down to the component itself. Is it, rigidly fixed? Is it a thin wall? Is it a thick wall? Do you have thick to thin, etc., right? In terms of thermocouple placement, oh my gosh, that's so critical, right? Because you don't want to be putting your thermocouples or your thermal monitors on a piece that outside your kind of soak band where you're going at that, because you're not going to get the accurate readings. I'm a big proponent to sit there and say, okay, I'd rather have more than less. They always pop off. People that have been in the industry, they know that better than I do. Somebody's walking around and kicked a bucket and, there goes their thermocouple or whatever. So super critical to get those on there. You really want to understand, what is happening to your component, right? You don't want to be like, oh, yeah, it's kind of on there. It's good. Should be fine, right? No. These things can get very sophisticated. You don't want to sit there and pull them off and not have accurate readings or whatnot. I had a repair. It was a really interesting one where it was a type of material. It was an 800 HT, I believe, and they had to do a solution anneal on it. They had some repairs, unplanned, and we get in and they're like, oh yeah, we're having cracking problems. Like, and I was like, okay, let's talk about, did you solution nail it? They're like, yeah, we solution nailed it. I'm like, okay, cool. Had a few meetings, got all the information, went through the history. I'm like, man, I can't freaking figure this out. Why is it cracking? Like they're telling me they went to the right temperature. They're telling me they held it at the right time. So I was finally like, do you got the heat charts? Like, let me see your heat charts, right? And I go through and they had slow cooled this. And this type of metallurgy, you need to rapidly quench it, just like we talked about earlier. And they were actually putting the component back into a state that was not as weldable. Mm-hmm. And you sit there and you're like, geez, like, and it's these things where it's like they wasted a lot of time and a lot of money on an unplanned aspect to sit there and just be basically fucking the dog, right? But yeah, so they were able to go through, do another solution nail, slow cool that, and repair was successful. But yeah.
Now, that whole thing, like, just completely baffles me because everything I learned, and I don't know a whole lot about metallurgy, but, like, when you heat something up and then you quench it rapidly, that usually causes it to be, like, hard and brittle.
It can be. It depends on the metallurgy as well. So
it depends.
It depends.
It's like the fallback. That's the solution for everything.
It depends, right? Right? It's like that scapegoat there.
Yeah.
Depending on what the metallurgy is, so certain things like carbon steels and low alloys or whatnot, yeah, if you do rapidly cool it, you will get, increased hardness or whatnot. Things, similar like high nickel alloys or stainless as well, austenitic stainlesses in particular, you may not get that. It's not as susceptible to increasing the hardness with that cooling rate.
Okay.
But yeah.
And then when you do that stuff, you don't like sugar anything, because I know a lot of times like you've got purge gas on the inside, you've got welding gas on the outside, and that's because that material's been brought up to a specific temperature, and then that's when it interacted with oxygen. So you don't have that problem when you're doing solution annealing.
I personally haven't ran into this. Not saying it hasn't or it doesn't happen, but I haven't run into it in my career thus far. So
okay.
But yeah, you can cook the shit out of your steel.
Yeah, I was going to say, like, even with stainless, like you get up to like 500 degrees, right? You start getting all the blues and the purples and all those different colors. And I was just wondering if that would happen on a whole section, if you're preheating it up or preheating it up to like 1,500, 2,000 degrees, and then all of a sudden you just quench it with water.
Right. Yeah.
But it's all wrapped too. Like it's insulated the whole time. So I guess it's not really interacting with the oxygen. I got to see this stuff. Like there's so much stuff that I haven't like gotten into in the welding industry. Yeah. Like I tell everybody, it's such a vast, skill or like a vast trade. There's so many different things. You can go, your whole career without seeing a lot of this stuff, depending on industry of welding that you're in.
Totally. Like, and that's the one thing, like, I count myself very, very lucky. I'm always a hands-on go-getter, and I've seen a lot of things in my life on multiple times in my short experience to date that some people haven't seen in their 40-year careers.
Yeah.
So, and it's totally that, like, you can find specific aspects in just like TIG welding or stick welding or whatever, right? Mm-hmm. So, and there's so many things. You're always constantly going to be learning something. Like, somebody once showed me like knowledge boxes, and like if I had a piece of paper, I'd draw it out. But it's like you got a little box, and you're like, okay, you're at the corner of the box down here, and you're like at the very corner bottom, and you're like, the amount of knowledge that they have that is out there is at the opposite corner at the top. So then when you get to that corner, then there's another box drawn. You're like, oh shit, man, there's more over here, and it just expands and expands and expands and expands. Like, I don't think we'd ever be able to get all the knowledge. And I always joke around. Have you ever seen Indiana Jones and like the Crystal Skull? And the lady is just like, she's like, I want to know everything. And she puts it on and like her head explodes. Like, I feel that would happen to us with welding because there's just so much stuff out there.
Yeah, and you can't you'll never know everything about welding. That's why it's great to come to like these summits and conferences, because you get to meet people that are like kind of inside your wheelhouse, but like they're a little bit further ahead in their career.
Yeah.
And then kind of bring you up to speed a lot faster. So you're not doing a lot of trial by error. You can figure out, I'm sure there's a lot of people that came out here and had conversations and, now they're going back to their company with, hey, I've got a solution. I figured it out. And they're like, how the hell do you manage that?
Yeah.
Well, I talked to so-and-so and he's been doing it this way for 30 years and it works all the time. And it's a proven theory or, proven idea that and it works.
Oh, totally. Like, I'm a big fan of mentoring and being mentored. I have like, a very healthy amount of mentors in my life, and I am like so blessed to be able to send them a text message or call them up. Could be 2:00 in the morning and I can call Bill Newell and be like, hey Bill, I got a problem.
Yeah.
How the fuck am I going to deal with this? I've thought about all of these things. It's like, oh yeah, we did this back this time or whatever, and we did it this way or whatever. And he goes down and explains to you not just like the theory, but also the practical side. right? And as you mentioned earlier, like there's a lot of welding engineers, I swear to God, they don't even know how to put their boots on, right? You know, and to each their own, everybody has their own skill set. And I rely on a lot of those folks for like very intense theory aspects, right? Where I'm more of a practical hands-on person that kind of liaison, if you will. But here, like you get all walks of life. You get people from all different corners and all different specialties. And like you said, just sitting down and having a couple drinks, or, you know, in my case, typically a few too many, right? You can get a lot of information like real
in a short
quick.
amount of time. Yeah.
Oh yeah, and like the AWS is fantastic for that. ASME, API, etc. Like I try to get on and talk to as many people as possible because that's where you learn, you know. And a lot of these folks are retiring, right, or are not going to be here around, right? So it's like I want to sit here and absorb up as much as I possibly can. Have those conversations, you know, shake hands, kiss babies, you know, right? And hang out with, you know, one of my prior mentors. Her name's Sherry Atchison, fantastic metallurgical engineer. She's like, you got to roll with the guys with gray hair and mustaches.
Yeah.
Right.
And that's the thing, because like I was telling you the other day, like I go to these different seminars, conferences, like I always try to keep skilling myself up, like, you know, lifelong learner. And, you know, the seminars, I mean, they're great, but it's a very structured presentation. You know, they do a little bit of Q&A and that's pretty much it. You're on to the next seminar. But it's later on, you know, like at the bar or whatever, out to dinner, you're having a drink, and you can start pulling so much more information and having much deeper conversations about very specific things. And like you said, you surround yourself with the people that are 20, 30, 40 years older than you are, and they're just brain dumping knowledge, you know, and they want to give this information freely because they don't want you to make the same mistakes. Yeah. You know, so you find these mentors and you start logging their numbers in your phone, and now you've got contacts. So when you're out there and you're scratching your head and you're like, man, we can't figure this out. You know what? I know Bill has been doing this stuff for 30 years on this specific type of alloy. Let me call him. And he's like, oh yeah, we ran into that back in 82. And, you know, here's what you need to, you know, do this and that. And the next thing you know, boom, the system's back up and running, and you're off to the races.
Oh, 100%. Like, you know, and again, touching on, you'll never know everything, but like if you can go shake hands and get those numbers and have relationships with those people, like you said, I have never had a time where I've sat and called or texted or emailed or whatever, and somebody's like, oh, no, I'm not going to tell you that.
Yeah, I don't have time for that.
Yeah. No, every single time. Like I said, it could be like 2 or 3 a.m. in the morning. It could be like whenever. And everybody's sitting there and say, hey, yeah, let's talk about this. You got a minute for a Zoom call? Like, let's jump on a call right now. Yeah. And you sit there and you have those conversations, and it's fantastic because they tell you the good, the bad, and the ugly, right? They give it to you all.
They don't sugarcoat it.
Oh, they don't sugarcoat it. And us in the welding world, we're not, we're not for the faint of heart.
Yeah, that's true.
Right, you know? So, no, it's, you know, these guys are stand-up people. They're really the movers and shakers, and to be able to know them and say, hey, I got a problem. What do I do? Like, for Bill, for example, I called him up and I was like, hey, I got, you know, a client that's trying to do a kind of an atypical weld procedure. They need, this vessel's going to be fabricated for, I think it was like 316H or whatnot. And then they want to put a carbon steel overlay on the inside. And I was like, what the fuck do they want to do that for? I never found out exactly what the process was for the vessel. But I was like, man, that's kind of weird. It's like a reverse overlay in a sense. And they're like, oh, yeah, we need it for the process, this and that. We can't pass the weld procedure. We can't qualify the welders. We can't do this, whatever. And I'm like, oh, like, we should be able to do this, you know? You can weld anything, you know? The thing is it going to be, like, are you responsibly welding it and are you compliantly welding it? You know, a little different. But they weren't passing anything. So I was able to call Bill up and I've said, hey, we looked at all these things. We did that. We did this. He's like, sweetheart, I got a filler metal for you. And he pulls out of this random filler metal, and I was like, I don't even know what that is. Like, I've never heard of that. I put it on the Google machine, very little about it. He's
Google
like,
doesn't know anything about it.
He's like, oh yeah, exact same thing. Like, oh, we've been using it since like the 70s, and we only use it for these applications. And I was like, where the fuck do I find this?
Yeah.
Like,
hold on, I got a contact for you.
Yeah, exactly. And he's like, oh, I know a guy. And I was like, perfect, right?
Yeah, no, it's really cool to be able to, like, when you run into those situations, to be able to have somebody in your Rolodex or, you know, your phone to reach out and have those conversations. Yeah,
no, it's fantastic. And then, like, you look like a crazy hero when you go and they're able to fix or repair or get the guys out welding, like, you know, and it's great. And, like, you always got to give the credit where it's due. I always sit there and be like, hey, this wasn't just a me thing. You know, I called X, Y, Z and these guys or whatnot. So you always got to sit there and put the credit where it's due. But, you know, make sure you have those conversations. I do sanity and crazy checks all the time. I'll be like, hey, I got this problem. I thought about this. This is what I'm doing. This is I'm out there in the shop with the guys. This is kind of what we went through. Like, what do you think? And either it's like, Paisley, you're fucking stupid, which is never, they never do say that, right? You're like, okay, try again.
Way off base here.
Yeah, you went way out to left field, right? Or it's like, no, you nailed it. You're right on track and everything from in between. And it's really nice to be able to say, hey, you know, I did all of these things. Am I right? Am I wrong? Because in the welding world, like, you know, there's not always a right answer, right? Or there's multiple right answers. So it's just like, how are we going to get this, you know, welded up and ready to go and get the plants up and running again, right? So
now, when you have these shutdowns and repairs, do you ever, you know, run into issues where it's like, hey, you know, before we start cutting this thing open and making this repair, let's set up a mock-up with, you know, existing material and then some of the new material and figure out exactly what we need to do to get this right, and then start cutting it apart and doing some, well, NDE and then some destructive testing as well.
Oh, 100%. I love mock-ups. If I could mock up almost everything I did, it would be great. You know, we don't usually have the time or luxury for that. But no, especially when you have these very, like, sexy alloys where it's like, you know, we can't get this. Especially now. Like, I don't know, you can't get material to save, like, your grandma, so to speak. So it's like, if we go and cut this up, we're hooped. Mm-hmm. So go do the mock-ups. I always sit down with the guys. I get behind the shield. I sit down. I'm like, hey, guys, like, what do we need to do? How does it feel? What do you feel like? Okay, can we weld it in this position? Can we weld it in that? Because, like, let's be real. Doing a mock-up in the shop, you know, on the flat position versus upside down, you know, hanging up from your boots or whatnot on the field or the unit, completely different. So I try to sit there with the guys and be like, okay, this is what we're doing. That's how we got to do it. Do with the mock-ups. Go test it all. Just, like, rip it apart. Metallurgical samples. Huge fan of that. Just to make sure, like, when we're out there and we're actually doing our production weld, that, you know, we know what we're doing. Yeah. This isn't just
we've practiced, you know, and we know it works.
Yeah, exactly. We're not sitting there and just being like, well, let's try it, you know, because you'll waste a lot of time and money. Mm-hmm. And usually you end up, like, wasting more because you have to go back multiple times, either in the same, like, outage, or you're like, oh, we just got to button it up and, you know, we'll make the run for another couple months or maybe a year, and then we got to take it down and do it again. So why not take the time now to do your mock-ups, work with the guys, and they'll sit there and appreciate it, and they say, okay, yeah, now I know how to weld it, you know, this is how I'm going to go through it out in the unit. And you really build up their confidence too. I don't know how many times I've done in-service, like, welding for leak boxes, because, like, there's been a hole through, or it's, like, basically on the verge of holing through, and you're like, hey, you know, here's your sticker, goes there and fucking weld on this. Yeah. And they're looking at me like, I got kids and a wife, you know. So I was like, okay, let's go practice. Like, let's get into the shop and, like, you know, we'll get material that's the same thickness, same metallurgy, etc. And we practice in all positions, right? Different amperages, etc., right? Different travel speeds and everything, just to make sure, like, you know, when they're out there welding on this stuff, that they're going home. Yeah. You know. We don't want to have anything bad like that happen.
Yeah, that's the biggest thing, because, like, where y'all are working is like a very dangerous environment.
Totally.
You know, you want to try, and I didn't realize it, but, you know, when I was talking with some of the folks that work here in Houston, they do these outages and shutdowns. You know, before they fire that plant up, they try to clear everybody out, like all non-essential personnel, like, get out of the way, you know, way back. Because once we fire this thing up, you know, we're pretty sure this is what's going to happen. Mm-hmm. But historically speaking, you know, we've had some, you know, things go wrong.
Oh, definitely. And, like, I've been on sites, and I'm not going to name any of the sites, but where there has been things that have gone wrong, and very significantly, and we have hurt people. Fortunately, most of them have been able to get back on their feet and all that jazz, but some people haven't. And it's scary as fuck. Like, you know, the first time you go out there and you feel it. You feel, like, these explosions. You feel the fire. And you hear it, and you're out there and you're like, holy fucking shit. So that's why it's like, especially in the welding side, we're not just slapping filler metal on there. Mm-hmm. Like, we're making sure our plants and our equipment are reliable and safe to be in. You know, you got to go and do inspections, and we want to make oil and petrochemicals and, you know, X, Y, Z. We want this for our, like, everything that we do. So let's do it safe and make sure we're doing it right, and it sticks together and we're not causing issues, right? So, yeah.
And that's one of the things that people don't understand. They're like, oh, yeah, you know, like, especially now, you're like, we're doing this. Everybody's going green, which, you know, that's great. You know, let's be great to the environment and good stewards, you know, the planet. However, you know, you have all this petrol. Okay, we're not going to put the petrol in the cars anymore. Okay. Mm-hmm. But all the electric vehicles, you know, they need oil that go inside, you know, all the boxes and everything to make the motors turn and all that. So there's a lot of oil that's going to go in that. And then plastic is huge. Like, there's a lot of plastic plants that they literally just make pellets. Yeah. Like here in Houston, I found all this out this week. They make plastic pellets from petrochemical, and, you know, all that stuff gets shipped overseas or it stays here. And this is how we make all the plastics in our home and like the stuff for our cell phones and the stuff for the interiors of our new electric cars. Like you still need all these plastic components. So petrol is not going away. So we got to figure out a way to keep these facilities up and running, maintain them safely, and do it correctly.
Totally. Like, it's huge. I recently walked onto a site to go for a shutdown, and it was like a styrene, styrene plant. And I was like, I don't even know what this is. And they take exactly that. They take the byproducts from oil refinement and they make like airplane glue. Really funny story about that. So I was coming into the QA office, right, you know, from the field, and I was going to go chit chat to the guys, and they're having a conversation, and there's this big old chunk of like, I don't even know what it was, like yellow shit. And I pick it up and I'm like, oh, this is pretty light, you know, and I sniffed it and I was like, smells like glue. And the guys were like, I don't know, Paisley, I don't smell glue. And I'm like, it was kind of funny. I was like, oh yeah, I shouldn't have said that. But, you know, I was like, what is this?
Reminds me of the days of huffing glue when I was in elementary school.
Right. And they're like, oh yeah, that's styrene. That's what we make, you know? And I was like, oh shit. Like, and they make airplane glue and bags and all that stuff.
Expansion foam that everybody's using for insulation and all that. Yeah.
Yeah, totally.
It all comes from petrochemical.
Yeah. And then same, I did another plant. It was like a methyl ethyl ketone plant or something. Oh,
geez. That shit's nasty.
Oh, it was crazy. I've seen, like, that equipment was probably the craziest things and interesting. And they freaking make, like, from the waxes and everything, they make, like, lipstick and, like, lip chap and, like, all these random things. And I was like, man, I never knew, like, we make lip chap and lipstick. From
so MEK, methyl ethyl ketone, that's some dangerous stuff. But they use that a lot in aerospace, I guess. You know, with, like, when they're launching rockets, MEK is, like, a big part of that.
Really?
Yeah, some of the guys that I used to work with when I did iron work, they worked at Cape Canaveral. And that was one of the things that they were briefed on before they went in there is, like, MEK.
Yeah.
Because it's some nasty stuff. But again, it's an essential chemical for some of the things that we have to do to keep, you know, things up and going and explore space or, you know, whatever the case may be. Or, you know, maybe it's an additive in cosmetics or, you know, in low doses or, you know, whatever the case.
Yeah.
But yeah, there's like so much stuff that's made out of petrol. It's insane.
Yeah, it's crazy. Like, you know, I personally like being able to wake up and turn my lights on. You know?
Yeah, that's always a plus.
Right?
And if it doesn't, you're just like, oh shit, I forgot to pay the power bill.
Yeah, that's the first thought. It's like, did I pay my bills? Right?
You're looking out, you're checking the neighbors. You're like, are their lights on? We have an outage, or did I like forget to, you know, send in a payment?
Yeah, exactly. You know, I like to put on my lipstick every day. You know, I like putting on my clothes, and it's these things like, you know, I step on sites all the time, and I'm like, I don't even know what this plant does. First of all, explain it to me, right? And dumb it down really simple because I'm not a process person. So it takes me a long time to understand what's going on. But it's always like, there's something new. And I'm like, oh, that's how they make that. Yeah. Oh, that's what this is. And like, that's a really cool thing about welding is like your skills are so transferable because you can go anywhere, right? You can literally go and work in like, you know, a cookie factory, like no joke aside. You can go work in a refinery. You can go work in like aerospace or automotive or structural, right? You know, anything. And welding's there for most of the parts. It's everywhere.
I've got buddies with rig trucks. I mean, that's what they do. I was like, what type of welding do you do? They're like, whatever pays the bills. I was like, elaborate on that a little bit. Well, you know, I'll do some like food process stuff over here. We'll do a shutdown over this place. You know, if that's not going on, we got structural going on over here. There's a brewery that's popping up, so they need some sanitary welding. This place over here needs repairs, you know, heavy equipment. I mean, there's all over the place. And that's the cool thing about welding is, especially if you're multifaceted, if you can run multiple processes, you're highly, highly valuable. You know, because there's a lot of people that can only run stick. They can only run flux core.
Yeah.
But if you can learn all those different processes, I mean, there's like no limitations of where you can and can't go. And you can always pick up new skills.
Totally. Right. And especially with different metallurgies on top of that, too.
Yeah, that's like, a whole other ball of wax right there because you got different alloys, and different alloys require specific things like pre and post heat, you know, and, you know, all the different tests and everything that has to go in it.
Yeah.
I mean, there's so much to it.
It's crazy. So, like, even just, like, you know, manipulating and moving the puddles.
Yeah.
So
it's, like, completely different on steel as it is on stainless. And then you start welding on Inconel.
Yeah.
And that's like welding in mud.
Yeah. It's crazy. And, like, I didn't appreciate it as much until I got behind the hood. And the guy, it's like, you know, we were failing these PQRs. And I'm like, what the fuck is going on? We have the best guys. Like, you know, one of my favorite freaking Boilermakers. He's amazing. His name's George Graham Jr. He's, like, stand-up guy. Whenever there's something crazy, he's the guy that welds it. He can weld like upside down, backwards, and mirrors. You know, it's nuts. And we're like, why aren't we passing this? And he's like, oh, this, that, blah, blah. And I get behind the hood, and I'm like, oh, I see it now. And he's like, it's just tricky, right? And it just takes, that's where mock-ups come fantastic, because you sit there and you practice. I call it play plate. I'm like, where's your play plate, boys? You know, I usually get a good couple laughs out of that. But, you know, it's huge because, yeah, those Incos and all that stuff, yeah, they are trash to weld, right? So you really want to sit there and practice all that.
Yeah, and it doesn't look like it should. Like any other time, you're like, oh, yeah, I'm just going to lace this thing in there.
Yeah.
And you're trying to get that perfect bead profile. And it's, no, that's not how this alloy works.
Yeah. And then same with like gases, right? So we were doing Hastoy, which is a alloy C276, and we were doing an STT root and a flux core fill and cap, which is very atypical. I had to like pull from whoever I could possibly get to get that filler metal, because a lot of people just don't make it. And yeah, we went out there and the guys wanted to save, the turnaround guys wanted to save money and cut costs as they normally do.
Oh, yeah.
And they're like, just use the tri-gas, you know, just put some argon in it, this and that. And the guys are like, this looks like shit. I go down and I'm like, oh yeah, it does look like shit. I think we looked at the pictures or whatnot, you know, and I was just like, oh man. So then, and turnaround's like, no, we're not doing it. Send in the PQRs. It doesn't look pretty, whatever. It'll pass. Fail. And I'm like, fuck, guys. We need the right gas. Like, you know, fork up the cash. You just spent more money fucking around with me shipping these pallets of plate off than you could have walked down and picked up a few bottles of proper gas.
Yeah. A couple $100, you get the right gas in there, and then you save yourself a lot of headache.
Totally, right?
That's always like it's a nickel holding up a dime, or a lot of companies, they'll want to spend $1 to save a penny, and it just doesn't make any sense. It's like, do it right the first time. You know, if you know what needs to be done, don't cut corners, because it's not going to work. And that's why the welding procedure is something we should follow. And these are considered essential variables. Essential meaning we have to do it this way. Yeah. Let's not cut corners and try to fake the funk and be like, you know what, they didn't know what they were talking about. Let's just throw some 75-25 at it and see what sticks.
Yeah, no, totally. And like to the other point where it's like, you know, even if you walk in, you're like, I don't know what to do here. So like, let's do more inspection. Let's really sit down and think about it before you just start, you know, chopping shit up or throwing like material at it. Because, you know, you may only have that component. So really sit down and like front end load. Like I'm a big person that wants to say, let's spend the time and money in the think tank now versus going back and redoing it. Because I've had jobs like, you know, you go through and they're like, we need this now, blah, 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 blah. And you're like, okay, cool, yeah. Everybody gets all pumped up and excited, you know, right? And sometimes it's really hard to go back and be like, okay, let's calm down. Let's think about this. And you go out to the field, get it all mowed in and this and that, and then you fuck it up. Yeah. And then you're down even longer. And then you got to go back and figure out, how did I fuck it up? How should I have done it properly, right? And then rehash all that out again, right? It's crazy. So you really want to sit there and think about it and like practice on your plate. Like, let's do mock-ups. Let's do this. Like, you know, can we take a boat sample, which is where you take a little piece of the metallurgy and then you do a metallurgical testing on it, like, you know, for micros and macros and stuff to see like, hey, like, what is this going to be like to weld on, right? You know, because there's a lot of times when you look at those grain structures, you're like, oh, this is going to be fucked up. Yeah. Right. So, and then usually from there, you can call your buddy or whoever and be like, okay, hey, we're seeing this. What do you think? Do we need to do this type of heat treatment? Do you think about that? Like, what do we got to do, right? So, yeah.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Everlast Welders. Check them out online today at everlastwelders.com. They make welding machines and plasma cutters for every skill level and budget. Whether you're a home hobbyist or welding is how you pay your bills, Everlast has a machine to fit your needs. And all Everlast IGBT inverters come with a 5-year warranty. And don't forget to use Arc Junkies in the comment section at checkout to get that free Nova foot pedal and Take Torch upgrade when you buy any machine that comes with a stock foot pedal. Everlast Welders. Weld mean, weld green. We're also brought to you by O2 Armor, the concealed nasal filtration system. I've been using these things a lot more lately since I'm doing work in a lot more people's shops. Indoor air quality is always hit or miss, and that's why I started carrying O2 Armor in my tool bag. O2 Armor is a concealed filtration system that filters out dust and airborne particulate down to 2.5 microns. The filters are easy to use, comfortable, and the coolest part is you can actually see how well they work once you take them out at the end of the day. Cool, gross, it's subjective. Check out O2Armor.com today and save 10% at checkout when you use ArcJunkies10 in the discount box. Breathe it or block it with O2 Armor. We're also brought to you by Strong Hand Tools. Time is running out to take advantage of the summer deals on Strong Hand tables and kits. Hop on over to stronghandtools.com/promo and get 20% off plus free shipping to the lower 48 states. Strong Hand has everything you need to decrease your fabrication time and increase your accuracy. They also have great safety and convenience tools from around the shop as well. If you've been holding back on picking up a new table, now's the time to take advantage of these awesome deals. But you gotta hurry. The summer promos end September 30th. Now let's get back into the show.
Yeah, planning is critical. There's two things I've learned in this industry is proper prior planning prevents piss poor performance. And then an ounce of prevention is, worth a pound of cure.
Yeah.
And so like if you can figure these things out before you go into it, like, hey, let's I know everybody wants to get the work done.
Yeah.
We got to get this stuff done. It's a rush job, but let's stop and think about it so we can get it done right the first time.
Yeah. Yeah, totally. Like, you just got to sit there and think about it. And it's hard, and I'm a very excitable person, as you probably can tell, so I'm like, yeah, we're going to go fix it. It's going to be great. Like all this thing's fucked up. People are running around. They're like, we need this and we need that, and blah, 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 and I'm like, yeah. It's going to be super fun, and then it's like, okay, like Paisley, calm your fucking tits. Okay.
Let's back a little bit.
Right? Yeah. Throttle down, right? And let's think about this. What needs to get done step by step, right? And then taking that information as well and what you want to do and all this and how you're going to do the repairs and then like communicate it to people. Because like I've been in meetings and stuff where we have a repair and like you're sitting there talking about how you're going to repair it and somebody's like, hey, they speak figurative this language, right? The lingo, right? Especially the guys out in the shop in the field, they got all the welder talk, this and that. And then you've got like, these corporate uppers or management and all that stuff with their, hoity-toity fancy words. And I've seen conversations where they've been arguing and I'm like, guys, you're saying the exact same fucking thing.
You're saying the same exact thing. You're just speaking two different languages.
Yeah, right? And it's nuts. So you got to be able to sit there and like cultivate and be like, okay, this is what we're going to do. And like what you care about, because usually management cares about dollars and cents and time, right? And then, you've got like your inspections that care about the quality of it. You've got, the mechanical engineers or design engineers that care about, oh, it doesn't meet code, is it this, blah, 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 right? And you've got the welders that want to go out there and lay bead, right? So you got to sit there and be like, okay, what do you care about? What do you care about? What do you care about? And like, what information do I need to give you, right? So it's huge. Kind
of like being a mediator. And my buddy said that, a while back. He's like, there's a need right now, and like an ever-growing need of somebody that can just walk into the shop and translate between what the welders are saying and what the engineers and the inspectors are saying. So if you can go in there and speak both languages, you're leaps and bounds ahead of a lot of people because you got like standard terms and definitions, and then you have welder speak. Yeah. And a lot of times, like you said, they're saying the same exact thing and they're arguing over it because, it's almost like they're speaking two different languages because they're not using the same terms. Yeah. But they're saying the same thing.
Totally.
And, so there's definitely a need for somebody that could walk in there and kind of split the difference and say, hey, you guys are saying the same thing. Okay, now we can move on to the next, chapter and we can take a little bit from the welders, take a little bit from the engineers. Yeah. Okay, now let's, build the procedure around this and let's see if this works.
No, totally. It's huge. Like, and there's lots of terms and stuff that I've never heard, especially, coming down to the States. Like, there's lots of really interesting terms and I'm like, oh, like, I don't know what that means. New. Right? And you got to sit there and be like, hey, I have a stupid question. I don't know what you mean by this word. And so usually people are like, what? Because it's just a common term for them. But they'll explain it to you. It's huge. Like, and then, like you said, talking about between the welders and the engineers, oh my goodness, like there's so many welding engineers that go out there and they tell you like, oh, we're going to do this repair. Here's the heat input, right? Go by this amperage, this voltage, this travel speed, this, that, whatever. And you're looking at that and be like, I can't control the voltage that tightly, right? And what the fuck is this heat input? Like, great, that's cool. You know what they're going to do? They're going to look at that piece of paper, put it down, maybe, blow their nose in it or whatever. It's going to get sparked up, and then they're going to go and, like, actually weld what they
weld it the way they want to weld it.
Yeah. So if you sit there and be like, okay, cool, like, here's all these fancy calculations and this and that, and they're going to look at you, whatever. It's like, hey, here's some calculations or whatever, but, like, this is what, we should be doing, right? Like, that's where you get that plate. Like, I want you to get this travel speed. That's all I want you to do. Get that travel speed. And the guys are pretty consistent. It doesn't usually take them very long to sit there and get that travel speed. And then I know whatever they're set their machine at based off of the wire size or, the stick size or whatever, that like, okay, we're going to hit within that range of the heat input and we're going to be in a good zone. Instead of saying, oh, do this heat input, they're going to be like,
yeah, what the hell's that?
Yeah, like, So, but yeah, if I say travel speed, right? Done deal. No problem.
So, I mean, if you can walk over there and say, okay, hey George, I want you stay right here. When I tell you to, I want you to go from point A to point B, and I want you to try to get there in 17 seconds. Yeah. And then you go over there and you dial in the volts and the wire feed speed and say, okay, on your mark, set, go. Yeah. And you hit the time watch and be like, okay, stop. Okay, you almost made it.
Yeah.
Let's pick it up a little bit on the next one.
Totally.
Or, hey, you way overshot that. Let's slow it down a little bit. Because what a lot of people don't understand, and it took me forever, before I figured it out myself, heat input plays the greatest, variable in everything that we do when it comes to welding.
Yeah.
Because you get a lot of people that, they'll say, oh, you weld too cold. Oh, no, you weld too hot. But then when you cut them apart, the metallography is the exact same. And it's because the guy that was welding too cold, he was welding much slower. And the guy that was welding really hot welded much faster.
Yeah.
But at the end of the day, you get the same heat input.
Yeah. Yeah. It's huge. Like I had done some like practice plates and just to understand that myself when I first started welding. And I was like, okay, and like you said, running too hot, running too cold, right? That, typically that's going to be, you've got high amperage or low amperage. And it's like, okay, so I got some of the guys to go down and do low speed, low amps, or too cold, then too hot and fast travel speed. And I did all the parameters, chopped them all up in the lab and went and looked at them. I was like, damn, first of all, you can see a major difference in just the beads themselves, right? And then the difference in the heat inputs. And when you get down to it metallurgically, that can make or break a failure, right? For a repair, and you may not make the next mission run. So it's so important to sit there and understand that. But it's crazy because, you can get out to the same, there's many ways to skin a cat, basically, you can get there and run too hot or too cold or whatever and just adjust your speed. And, most people or most of the guys are really good at controlling their speed. You just, like you said, here's a little soapstone from here to here, go for it and let's work on it. No problem. Right.
Yeah. No, and that was a cool thing because I got to hang out. I don't know if you made it out to Scott's shop at his Republic Testing Labs.
Yeah.
He's got a legit setup in there. And as soon as you walk in, he's got this microscope and they're doing micros. It's 20 times zoom.
Yeah.
And it's insane. You take this piece of polished material, that's got the weld nugget and the base metal and all that stuff in there, whether it's a fillet or, a groove weld. They put it under this microscope and they can zoom in and it's just, it blows my mind, and his shop manager's explaining, he's like, okay, this is, austenite and this is ferrite. And I'm like, holy shit. The grain, looking at the grain, reading in a textbook's one thing, but we can actually say, okay, here's the weld sample, and we put it under this magnifying glass, and then we can zoom in and see the grain structure. It's mind blowing that you can actually see, okay, and from that information they can say, oh yeah, heat input was too much, or the heat input was too cold, or it cooled down too fast, or it got brought up to temp too quick. What you can see inside these samples is insane.
Oh yeah.
And then the feedback that you get from that, and you can say, okay, we're getting up, much closer to, the procedure. This one fails. However, let's go back and we're going to make some adjustments here, and then boom, run it. And then, they're doing Sharpies and tensils and all these other tests that go into it. It's just, once you start getting into the destructive testing, because you can't see it as a welder, you don't know if that's going to be a great weld or not. I mean, it looks good. I'm going to take a picture. I'm going to put it up on Instagram and it's awesome.
Yeah.
However, what you don't see is a couple days later when it starts cracking everywhere.
Totally.
Because there's certain types of alloys you can't even inspect until 24 hours after post-weld heat treatment.
Yeah. Yeah, it's nuts. One of my favorite things I would do, especially when I was in the shop, is whenever I did micros, and I always did micros, I'd just be pop that into the cost, be like, oh, you gave me a work order, so I'm going to use it.
Yeah.
Right?
Just going to sneak that in there.
I'm just going to plop her right in. But I start showing the guys, the micros, and they're like, oh my gosh, I can see the heat affected zone. I can see the HAZ. I can see every single pass on there. That one's way different than this one. And then you go back, and I'm a big, I like my...
documentation.
My documentation, and I see all my readings. Oh my gosh, the freaking thing, my little voltmeters. The name's escaping me, but
multimeter.
Yeah, it's it's a yellow one, big old yellow one.
Fluke?
But the flukes. Yeah, the flukes. It's great. So you can graph it on these things, and you have an app on your phone, and then you can see when your amperages go really high or not, and then you can track those, and then I can circle in and find that specific weld bead, if I've documented all of it, and that micro, and say it was that one. And then you go back and you're like, oh, something crazy went on over here. What do you do? Blah, blah. And he's like, oh, maybe that was when my wife texted me and she was getting mad at me for freaking doing something.
Yeah,
and
then completely
right?
completely changed the way I welded.
Yeah, it's crazy. But you can we have, the future is now. We can really go out there and do all of these things. It's just getting out there and showcasing
and doing it. You you can't do it in the office.
No, totally. You got to be out there, and that's one of the cool things when I was in the shop was I would, hook up my fluke and all this, and I could tell these ones are going to be really good and they're consistent. And it's not about the specific number. It's about the consistency. So, you know, after coffee break, he comes back and like he's running like super high or super low or whatever, and then goes off and it does another thing. So you see all these different steps, and it's like, well, maybe we should go and grind that one out. Like, you know, let's get them all consistent, right? And you can find it. It's crazy. You show the guys and they're like, hey, this is your weld. Like, this is what it looks like cut up and like, you know, microed and polished and all that stuff. It's fantastic. They love it. Yeah. They're like, oh, I had no idea. I'm like, yeah, this is cool shit,
start
man.
Welding nerd out. Yeah, you start welding nerd out on that shit.
Yeah.
You're going to have to send me the information on that fluke meter because now you get me really intrigued. I know with like the Lincoln machines, you can plug an Ethernet port in and you can watch the weld sequence on the back end. So you can see every single pass. I went to a weld procedure specification class, and that's how we wrote procedures. We're like, okay, pass number 1, you know, you tell the welder, hey, go ahead and weld it. You don't have to sit there and monitor the front of the machine and get your approximate amperage.
Yeah.
That machine's going to tell you, okay, here's your peak amperage, here's your voltage, the wire feed speed, and, you know, it calculates your heat input because of based off your travel speed. When you pull that trigger, arc on time. To when you stopped, arc off. Here's your heat input calculated, you know, all right there for you. And it tracks every single weld that you put in there. And then you can just hit the reset button and, you know, okay, that procedure didn't work. Let's go ahead and roll into the next one. Okay, now here's all of our parameters. And when you start doing like severe documentation on this stuff and you submit that as part of your packet to develop a procedure, like you can't be wrong. You've got here's exactly what happened. It's not like a snapshot like, oh yeah, you know, like I was in a bad mood and I really wasn't paying attention to the machine and I really didn't catch the second pass. I got distracted. I got a text, whatever. Had to send an email. You know, but I picked up around the 4th pass, so I just made, you know, the same, you know, pass number 2 and 3 were the same as 4. I'm guessing, you know, because nothing really changed. But no, this stuff is like, here's what happened during weld number 1. This is what happened during weld number 2. And it doesn't matter, you know, as long as it's a wire-fed process. Even I think it'll calculate on the stick welding applications. I'd have to double check that. But like all your data is right there. Now you have an entire documentation of what happened. And, you know, we can use this information to qualify this procedure once it passes all the, you know, the different testing it has to go through. And once again, that's proper prior planning. You know, and you've got all this stuff. So you limit the amount of rework and repairs that you have to do.
No, totally. Like, I freaking love it. Like, the fluke is really great, too, because you can, like, throw it in your back pocket, basically, of your coveralls or your boots or whatnot, and you can take it out to the unit. And, like, say your welding machine's down on the ground, right, and you've got cables ran up to, like, a couple platforms up, right? You're not going to be able to go running back and forth off of there. Maybe you're lucky and you've got, you know, an apprentice or somebody helping you out or whatever, and you're like, hey, turn it up, turn it down, blah, blah, whatever. But if you've got your fluke, you can sit there and, like, look at it right there and then, which is awesome. In real time. It's fantastic. Like, in the Lincoln machine, it blows my mind that these things aren't, like, super well known, because that's fantastic. You can sit there, if you're doing, like, repairs and any of that, if you have that machine in the field, you can tell when, like, I don't know if this one's going to be good. Let's, like I said, cut it out or let's grind it down and re-weld it. It's fantastic. You're really being very proactive on that in a kind of a reactive sense, but it's real time in there.
If you can catch it mid-work, you know, like saying, you know, especially on a lot of multi-pass stuff, and say, okay, we really shit the bed here on pass number 4. Like you said, let's go ahead and grind that one back out. That way, you know, if we're putting in 10 passes, we don't have to carve back into it to fix the one that's screwed up.
Yeah, and you usually don't catch that till, like, you know, you get your RT.
Yeah, you get the cap on there, and they're rolling out there with, you know, RT, or they're doing ultrasonics on it. And yeah, you don't want to catch it then, because now we've got, like, rework. I've said it 100 times. It's like costs 300% more than it does to do it right the first time. So if you can catch it in process, you're much better off.
Yeah, no, and it, like, helps the guys out there too, because it builds up their confidence. Like, you know, as big and burly and as tough as the welders are, they're pretty sensitive about their welds. You know, very sensitive. If you're like, oh, this wasn't good, they'll mope. They'll be sad about it.
I get a little upset if I put a bad weld in.
You know, right? So it's like, okay, cool. Let's get this confidence up, and, like, you got this, guys. Like, you know, you're the A team. Like, let's do this.
But I think like the engineers should, and I don't know how it is in every company, but I mean, like, engineers should be working really close with the welders. So that now the welders are becoming more educated, and they're catching themselves. You know, they know exactly what to look for because they know what the testing requirements are. You know, that's like why when I go in just to do weld certifications, I explain to whoever's taking the test, like, here's what I'm looking for. You know, this is, you know, the root pass, you know, no undercut. Make sure they understand what these discontinuities are, because they could call it something different. make sure we don't have any lack of fusion, kind of explain what that is. All your bead profiles should be uniform. And on the weld reinforcement, we can't have any more than X amount of, fractions of an inch or, whatever the case may be. Like these are the things that I'm looking for. Or when we're doing a fillet weld, say, okay, I need to make sure that you punch into the root of the weld and kind of like show them, like I got samples and say, here's what I'm looking for. And like, oh, okay, I get it.
Yeah. Like, show and tell, pictures, numbers, and words, right? And there's nothing better than having like those samples or this or being like, yeah, this is what's fucked up and this is what we're trying to avoid, right? I have full faith in you that you're going to do a good job on it, but like, let's figure out how to do that. And like you said, as soon as you show people, like, this is what I'm looking for, this is what I want the output to be, they get it. Yeah. Like, they know how to sit there and manipulate and go up and down.
They're not dicking around trying to do trial and error on it.
Yeah, totally, right? And like, I get it all the time. Like, George texts me quite often. He's like, hey, what's this? Or what does this mean? Or what's that, right? And you sit there and like, you chat about it, this and that, and like it's like, oh yeah, okay, that makes sense. That makes sense why that's happening when I do this. And I'm like, okay, yeah, I didn't know you were doing that. So tell me more about that, because I want to know what doesn't work for them too. Like me coming in and just talking at them isn't going to help. Like I learned so much from the guys, like so much. It is unparalleled the amount of knowledge that the guys on the shop floor and out in the unit have. It is awesome. But like you said, there's not a lot of engineers that actually go out there and talk with them. They don't know how to put their boots on and tie them up, right? I always tell people I can put my boots on, tie them up, and walk my ass out the door too, right? Multifaceted over here.
There you go.
Right? But it's definitely really, really important to have those conversations. And then you start to pick up the lingo, right? If you don't ask, well, at least you're going to be around it a lot more, that you're going to be like, oh, that's what that means. Okay, I got that, right? And then you get more street cred too. You're like, hey, he or she or the engineer is not just sitting up in the ivory tower. Like, they're actually out here. They care. They care about what I'm doing, and then they want to teach you stuff too. And that's how, again, I start welding. I was like, well, what's this and what's that? And how do you do this? And, I want to do this. And the guys are like, you're not going to fucking do that.
Yeah.
Like, have you been up in the unit? I'm like, yeah, I've been in the unit. I looked at that. They're like, okay, cool. How hard was it for you to get out there and get into the unit and go look at this or this piece of equipment or whatever? And I was like, and I'm not a very big woman, right?
Right.
And I was just like, oh, it was a kind of a bitch to get up in there. And like, yeah, now try having a stinger or a freaking wire feed up there. Like, how are you going to do that, right? With your pack and all your full face and yada yada and a spark watch and all this stuff. And I'm like, oh yeah. I didn't think about that.
Yeah.
Right.
You got to get to the work before you can do it.
Yeah, exactly. So I've learned so much from the guys, just being around, just hanging out, going down. Like I used to smoke, don't smoke anymore. When I just go have a smoke break with the guys and just chit chat, bullshit in this. And they're always talking, oh, this was shit or this was good or blah, blah. And it's like, okay, cool. Yeah, I get it. I'm starting to get it. Right.
So I was talking to one of the other engineers and he did that the first couple of weeks, like he was like fresh out of engineering school and went into this shop and they were like, you don't know the hell you're talking about anyway. He's like, you're right. Can you teach me?
Yeah.
And so like the welder and the engineer, they spent 2 weeks together and like, they became best friends. And I mean, that was like 20 years ago or whatever, but now they were like best friends to that guy's entire career. And he's more understanding of what the welders are actually going through. And the welders, they now understand, here's the expectations. Here's what they're looking for. And I can do this just by changing my technique or monitoring my wire feed speed and amps and volts and travel speed and all this stuff. It's crazy what all these different variables do.
Oh yeah, it's nuts. Like, it's a beautiful thing. Like, welding is very sexy.
It's like a symphony.
Yeah, it is.
Everything's got to come together.
Yeah, exactly. And, you can do it in many different ways. You can have like, multiple instruments or less instruments and, they all turn out really nice, hopefully anyways, right? But yeah, it takes two to tango, right? That's the goal. Yeah, right. It takes two to tango. You got to sit there and have those conversations. And don't get me wrong, like, it's awkward. Like, I show up on sites all the time and they look me up and down and I'm like, who the fuck are you and what are you doing here? And I'm like, I'm the welding engineer. And they're like, okay,
great.
Cute. Why don't you go over there and fuck off and go play in your sandbox and, tell us some information that's probably not going to work. So the first things I always do is I find out, like, do they smoke? What do they like? Blah, blah, blah. And go start bullshitting with them. I'm like, hey, let's meet up. And then they start to realize, like, hey, you're not just like an engineer. Like, you're actually like kind of knowledgeable or this or that. And they start sussing and feeling you out. And you're doing the same too. And then I've done turnarounds where literally somebody told me, like, what are you, fucking 18? Get the fuck out of here. And I sat in the door and I'm like, I don't even know how to respond to this. But okay. And I'm like, well, at least I'm here. I'll go fuck off over there. No problem. Where's the coffee machine? Can I use your cup? Right? And he looked at me and he's like, what the fuck? Grabbed the cup and walked out. But then by the end of it, like he called me up all the time and he's like, hey, what about this? What about that? Blah, blah, blah. But you got to build those relationships. It's so, so, so critical to do that. And you'll get faced with, you know, this being like, hey, you know, you're young or you're this or you're an engineer, blah, blah. And it's intimidating. Don't get me wrong. Like there's lots of big burly men out there that intimidate the fuck out of me. And I sit there and I'm like, hi guys, I'm here to help you with your repair. And they're like, I've been doing this longer than you've been
doing this 20 years. Get the hell out of here.
Yeah, right. But it's just sitting there and like talking to them, and you got to put your neck out sometimes, and just being like, hey, and sometimes it doesn't work out. Sometimes, you know, people just, they're gonna hate to hate, you know, and that's what you got to accept it. Just be like, okay, cool, no problem, you know, I'll do my little ditty and, you know, try to make this relationship, and if not, you know, that's fine.
I mean, those relationships, you know, on job sites, they're so important because you have to work closely together for, you know, a lot of people, especially, you know, when you do these shutdowns and turnarounds, repairs and stuff like that, it's time critical. You know, so they're working 7/12s for, you know, 3-4 weeks or even more. And so tensions are already high. I mean, you've got to have a good working relationship. You got to set the tone. You got to have a good rapport with the people that you're working with.
Totally.
You know, because at the end of the day, you've got to get this job done because it's mission critical.
Oh yeah, and like so when I used to work on one refinery or whatnot, and we'd always move over to the turnaround building, and the first thing I would do, I'd clear out the bottom drawer, and I had these little organizers, and I'd get chocolates, I'd get sweets, I'd get sour candies, I'd get chips, I get salty, I get all of it. Because the guys are coming, like you said, they're doing 10, 12, 16 hours, you know, 6 and 1, 12 and 2, whatever it is, you know, they're not being home with their families or doing what they want to do or even sleeping, right? And they come in all hot and horny, just be like, oh, blah, blah, guns blazing, and we need to do this and blah, all this stuff. And you sit there, I open the drawer and I'm like,
you want a Snickers?
You want to, yeah, do you want a Snickers? Like, yeah, right? Here's your sour key. There was one execution guy. Oh my gosh, it was so awesome. His name's Keith Bishop. And he'd come up and I could just feel him standing behind me, and I just open the drawer and like literally like hold a sour key over my shoulder, and I just feel it, like take it out of my hand, and I turn around, I'm like, okay, Keith, what's going on now? And he's like, I need you in the unit to go do this. I was just like chewing on his like sour key. It was like the funniest thing ever. But like, you got to sit there and like build those relationships. And like, honestly, like food's about
Welders like snacks.
Right, lots of snacks. Ones that easily go in coveralls too. Sour keys, awesome. I would never eat a sour key if he gave it to me because I know where it's been.
Never had one.
Right, but yeah, no, it's huge. Right?
No, it's really cool. It's about building those relationships, you know, kind of respecting one another. And I think you gain a lot of respect from the welders because, you know, you come down there and talk to them, speak their language, and you're actually interested in hearing what they have to say.
Yeah.
You know, and I think the same thing goes with like inspection. If there's a lot of inspectors that are come out there, it's like pass, fail, fix your shit.
Yeah.
Which I get that. I mean, it's not their job to build those relationships. But like when I work with people, it's like, hey, look, you know, I'm not going to give you a whole lot of guidance on this, but like, because I do have a welding background, I can say, you can fix this, or here's why it went wrong. Oh, nobody's ever told that to me before. And the next thing you know, they're better. You got a better working rapport. Next time you show up on the job site, they know exactly what you're looking for.
Yeah.
And then you go up there and you're like, okay, cool, bud. You learned from the last time.
Yeah.
And, you know, it's about cultivating those relationships and building each other up.
Yes. Yeah, exactly. Like, let's elevate. And like, we all know there's inspectors that are just like, shit sucks. You know, you failed. You know, stop fucking up. And you're just like,
figure it out.
Yeah, why you got to be like that? Like, come on. You know, he's just coming here to do his job, and you just like you are. Like, so I don't know if they're getting beaten up or they're just an asshole, because there's lots of those guys and gals out there, right? But it's like, yeah, let's have those conversations, and then you start to, like you said, educate and you understand like what's going on and why and the what's and the how, and like, you know, oh, I can do this to change that, or do this, or, you know, this is how they're inspecting it. And just like you said for the testing, like, you know, you show the guys like, this is what I'm looking for and this is what I'm not looking for, right? And they can sit and they can figure it out, right, ahead of time before, you know, going around and causing all sorts of issues. Like, I've seen full-on brawls with people over, like, you know, exactly that. Oh, your weld sucks. It failed again. And you're just like, it just triggers.
Yep.
And it's just like, whoo, like, okay, do I intervene or do I just stand over here? I don't know what to do.
Sit back and let them work it out.
Yeah. Right. I've seen wrenches go across the freaking booth.
It's pretty heated on a job site, especially when you're working all those, you know, excess overtime. You're away from the family, you're away from the house, and everybody's just tired, miserable, cranky, hungry, and like, they just want to be done.
Yeah.
Just want to be done and go home.
Yeah. Yeah. No, exactly.
Well, damn, it's been awesome having you on the show. I appreciate you taking time out of your day. I know we're both on a bit of a tight schedule, so we'll go ahead and end it. But before we do, why don't you tell everybody where they can find you as far as like social media wise or, whatever.
Yeah, so Instagram, I'm an Instagram gal. My Instagram is Paisley Natalia, just Paisley Natalia, Natal. I can't even spell my own name.
Damn.
Right? Lia. So I'm on there. You'll see it right there. I got a full-time engineer with the little welding girl emoji and all that. So go ahead on there. LinkedIn as well, Paisley Cameron. On LinkedIn if you want to hook up on that sense. And then yeah, I'm based in Calgary. So if you guys are in Cowtown, come hit me up and we'll go for a couple drinks or too many.
There you
go.
Fantastic. Well, it was great meeting you here at the summit. And once again, I appreciate you taking time out of your day to come on here and chat.
Awesome. Well, thank you. I appreciate it.
All right, everyone, that pretty much does it for this week's episode. I hope you all enjoyed hearing from Paisley. She's probably one of the coolest engineers that I've met along my journey. Be sure to tune in next week. I have a pretty cool episode planned out that should help everyone, regardless of where you are on your welding skills or what part of the industry or what sector you're in. It's a universal topic that's going to benefit everyone. Y'all stay safe out there, and until next time, make every weld better than your last.